Hello, and thank you so much for your interest today. I'm Ron Shevchik, Gore's application engineer for automotive lighting, and you're about to see a presentation I gave at the recent DVN West Coast workshop. It's mainly focused on battery electric vehicles and why they're especially vulnerable to headlamp condensation, and why industry trends make it even more important than ever to find an effective solution. Industry's trends. There's a lot of new technologies being incorporated into the lighting environment. Vehicle visibility systems, they need cooperative integrations of sensors, cameras, and mirrors. One thing is definitely clear moving forward, that lighting is going to be key to the driving experience, the ADAS performance, and the brand differentiation. All these new technologies within the lighting industry, all these diverse trends that have a single shared need, and that's condensation-free lenses. So electric vehicle headlamps are vulnerable to condensation, even though they typically run cooler than internal combustion engine headlamps. You may think that without the thermal mass of that internal combustion engine, that you're not going to have a condensation problem, but that's simply not true. You definitely still have a condensation problem with electric vehicles. All these new technologies are creating new causes for an old problem, and that old problem being condensation. So electric vehicle headlamp condensation can actually be worse than internal combustion engine vehicles. So you might be asking yourself, what's so different about electric vehicle headlamp condensation? It's the way the moisture moves. It's the way that moisture accumulates. It's just different in electric vehicle headlamps. And the actual issues that cause condensation, they're different as well. So we've got extensive on-car and climate chamber testing that really helped us understand and quantify these differences. We took all sorts of information from on-car testing and adapted it to work in climate chambers so we could really focus and study on what's happening with moisture movement within the headlamp. So first, let's talk about the primary sources of moisture. And this is going to be true for both internal combustion engines as well as electric vehicles, because this is moisture transfer with the plastic. Now, currently the industry is using the same plastics for both internal combustion engine vehicles and electric vehicles. So there's two main mechanisms of moisture transfer via the plastics, and that's going to be sorption and permeation. So sorption happens where moisture molecules deposits on the surface and within the thickness of the plastics. And there's permeation, which is where moisture molecules actually transfer through the wall of the plastics. And every plastic has its own permeation and sorption rates, and they typically run counter to each other. So you might be asking yourself, what's so unique about electric vehicles? It's the lack of that front engine. It's the lack of that thermal mass. So frequent drive cycles at lower temperatures can actually encourage moisture to accumulate, can prolong your condensation clearing times. Problem begins and builds up. So when you're driving your electric vehicle, the lamp temperature typically follows the ambient temperature by a few degrees. So these lower temperature electric vehicle driving cycles actually encourage that moisture to collect on the surface and within the structure of the plastics. Compared to an internal combustion engine vehicle, every time you drive your vehicle, you have that large thermal mass, you have that heat happening, which is actually drying out those lamps plastics. And so you don't have that anymore. So these repeated driving cycles at this lower temperature means you're holding more moisture is accumulating, which means you have a greater potential for condensation. So you're actually saturating those plastics as a result of these lower temperature driving cycles. Trigger event. So you have exposure to some external heat source, and that would typically be sun load or fast charging. So during a fast charge scenario, you have a lot of energy going into that battery, and there's cooling structures that pull that heat that battery's generating from the fast charging. They pull that heat up front to the radiators where the headlamps are. And there's a lot of heat trapping with plastic shrouds in the front area. And so that's now how your front lamps are heating up, aside from sun loading. And when that happens, all this internal moisture, these saturated plastics, when they heat up, it releases all that moisture into the enclosure. So now you have all those moisture molecules coming out of the plastics. It's like squeezing a sponge. You're squeezing all that moisture out, and all that moisture goes to the internal lamp environment and raises the dew point. Then you have the consequence. So this is exposure to some kind of external cooling event. And that would typically be like rain or wind, and that converts all that internal moisture that was just released into condensation. So when you have that internal dew point rise up and then you have that lens temperature fall, when those two meet or cross, then that's when you get condensation formation. Once you have that condensation, you need effective clearing. So there's two main methods to clearing condensation. And one is convection, which only works when the vehicle is moving. You need vehicle motion for that convection to happen. You need movement. You need air movement. You need airflow. You need airflow through the lamp. And that can only happen when the vehicle's in motion. So if you think about it, how often do you drive your vehicle every day? The typical person would drive, to and from work, maybe an hour. You stop, pick up the kids, stop at the grocery store, whatever it is. You're typically only driving your vehicle a few hours each day. And so that convection is only working for those few hours a day. Most of the day, the majority of the day, your vehicle is sitting, which means you don't have airflow, which means you're not clearing your lens, you're not getting moisture movement within the lamp. There's also diffusion. Diffusion works whether the vehicle's moving or not, whether the vehicle's on or off, whether there's airflow or not. Diffusion works 24 hours a day, 7 days a week. It never takes a break. Diffusion is always moving moisture in your lamp. So Gore vents work on the principle of diffusion, and that's the best way to clear condensation. Again, that diffusion is working constantly to move moisture from your lamp. So why does better clearing matter? There's a real industry focus on autonomous driving and sensor integration. So you have to think about this. What are the impacts of condensation on clear view and sensor autonomy? And what's the need for best-in-class diffusive venting, Gore venting, to mitigate that condensation? And what's the value of quality versus the risk of warranty costs and brand reputation? Nobody likes sitting in those warranty cost meetings. At this point, you're probably wondering, why choose Gore? Well, our thermodynamic studies have really put us at the forefront of understanding electric vehicle condensation problems and solutions. And more broadly, we really do think that Gore offers the total package. We've got a proven automotive portfolio, a track record of innovation, and a comprehensive global service and support, including supply chain stability. So thank you for watching. I really do hope you found this information helpful. Before you go, be sure and bookmark this page if you'd like to watch this presentation again. And if you have any questions or want to connect with a Gore Automotive Lighting representative, use the form on this page and we'll get back to you promptly. Thanks again for your time and have a great rest of your day.